All right, hello everyone. This is Jeff Scott of Rankin Technical College. And for some reason, for the online AWD1100 Programming Fundamentals with C# course, on the lecture I did on Tuesday, August 23rd, for some reason it cut out after an hour and 47 minutes. So I am re-recording the lecture for Chapter 3 of our text because it looks like that was gone. Now, I'm using Camtasia, which is a screen capture product. It's not Microsoft Teams. The reason I'm telling you that is this lecture will be available on my YouTube channel, but it will not be available under Microsoft Teams. It's much easier under Camtasia for me to go and switch from one window to another. However, I don't have the interactivity with all of you that I have when I use Teams. So, it says in the last chapter you learn how to design a form. And if you remember, we'll move back here. That's what we had done. We had created that form. Now, in the textbook, what they did was they created this form in Chapter 2 and they added the code in Chapter 3. I added the code right away. But I think that what we'll do is we'll go back and maybe I'll make even a copy of this and we'll add their code so you can take a look at what that looks like. So this is broken down into what, about 4 sections: an introduction to coding, how to add code to a form, some additional coding skills, and how to run, test, and debug a project. I do want to mention that for the gentleman who emailed me and let me know that part of the presentation was missing, I honest to goodness appreciate it. All right, I should do a better job always of watching these things afterwards, but sometimes they're 3 hours plus. So I usually just look at the beginning, look at the middle, and look at the end to make sure that there were no flaws in the taping, and I didn't catch this one, so thank you. All right, so one of the things that we talked about earlier, and I'm going to bring this program back up again, so let me do that right now. Let's see. Too much junk here on my desktop. That was a pretest. I don't know if I have it there or not, so let's see. Let me look on my desktop. And what was that thing called? Something with invoice total or something like that. Sorry, I should have done this beforehand. So it looks like that's it. Let's copy that here. And I'm going to have to bring it up in a little different way, but that's totally fine. All right, this might not be it, so I'll have to go find it. No, that is not it. This is the one from Muroc. I want the one that I created. Oh, brother. I think that's what I just brought up here, so let's see. Invoice total, that's from the desktop. That is not it. Okay, we won't go that route. All right, sorry if this is sounding a little flippy, but let's just go back to the textbook. If you look on the screen here, what you have, and you already know this, we've got a form. And that form has on it 1, 2, 3, 4 labels, 1, 2, 3, 4 text boxes, and 2 buttons. But the form is more than that. The form is an object. In other words, the form is part of the form class. Each one of these labels is a label object. It's part of the label class. Each one of these text boxes is a text box object, part of the text box class. And each one of these buttons is a button object, part of the button class. So as they say here, an object is a self-contained unit. It's code and data. All right? The class is the blueprint from which you create objects. And I believe I gave an example of this before, saying that if you were to build a house and you had an architect come over and give you a house plan, that house plan could conceivably be used to build lots of houses. All right, so the actual house plan, the blueprints drawn up by the architect, would be the class, where the houses themselves would be the object. Each time you create an object from the class, you're creating an instance of the class, and the whole concept is known as instantiation. Now, objects hold two basic things. They hold properties and they hold methods. All right, properties are characteristics. Methods are behaviors. So for instance, if I created a person object, that person object could have for properties height, weight, eye color, hair color, etc. And for methods, that person object could have eat, sleep, etc. Events are signals sent to an object telling it something has happened. Well, so far the events that we've been responding to have been click events to buttons. But as you'll see as we go on, there's other events that objects can respond to as well. All right, I think that's pretty much what I wanted to say from here. Okay. When you add a control to a form, Visual Studio automatically generates some C# code for you. We've looked a little bit at that. Now, when you're working with these objects, the good news is that your editor, which is Visual Studio, has built into it what's called Intellisense. So as you start working with these objects, Visual Studio will attempt to give you help by providing things that you can do. So in other words, maybe you notice this, that when you come in here and you type this, for example, txt dot, the Intellisense kicks in and you get a lot of different things. You get an alphabetized list of all the different methods, all the different properties that you can use with that, and text is one of them. So if I type in txt total dot and I type in a t, then it'll show me all of the properties that start with t, with r, etc. All right, so these are working with properties. When you call focus or you call close, etc., or as we've done with the application.exit, those are calls to methods. And you notice that method calls always have a set of parentheses on the end. If we left the parens off, the system would think that these are not methods, they're properties. So methods, again, they're behaviors, all right? And they have the parentheses in there. All right. Windows applications, like a lot of applications, are event-driven. What that means is they sit around and they wait for something to happen. When that something happens, that something is an event. And if there is code that is associated with that event handler, so for instance, if you click a button and that button has no code associated with it, nothing really happens other than the button may look like it was clicked. But if you've got code associated with that button, that code will fire. All right. And they use an example here of that exit. So when you click the exit in that click event, since there's code that says this.close, it closes the form. All right. You can respond to clicks, to double clicks. The enter and leave are more often than not going to be used, like with mouse enter and mouse leave. But basically, they could be any control. We've already looked at the load event, and we put a little bit of code in there. If you remember, we put in the last chapter, we put that 10% for our discount percent. We put it into our load event, so it was there when the program started. There's also closing and closed events, and the difference between these is the closing event. The form is in the process of closing, but is not yet closed. So this would give you time if you wanted to ask the user, hey, are you sure you want to do this? Or did you forget to do this? Or whatever. But in the closed event, the form is already closed. All right. So when you go and you connect this up, so when you come in there and you put this code into that event, it's known as wiring up the event because that's really what you're doing. All right. Now, I may have shown you this before. I may not have. I don't even know. Let's see once. I'm going to get, we'll look at this one. That's fine. We'll look at this one. So, if you go and you look at how this works, if I double click on the calculate button, all right, it brings up the default event for a button, which is the click event. And it has a sender, that basically is who or what initiated the action, and any arguments that you need. We're going to do, until we get to the database portion of the class, we're basically going to do nothing with this. It's just something that's there. All right. But quite often, let's say you were programming your own game, then you might pass into these events coordinates on the screen. So as you moved around, you would know exactly where you were, for example. Now, this is the click event, okay? It is the event that comes up automatically when you click a button. But notice if I double click on here, so if I double click on Miles, it brings up a different event, text changed. That event fires every time you enter any character or remove a character from a text box. If I go and look at the labels, that brings up, again, a click event for labels. So buttons and labels have a click event, text boxes have a text changed event, and the form itself, you've already seen this, has a load event. Now, the reason I'm showing you this is I'm going to go back to the button here, and I'll use that calculate button. And I'm going to come in here and I'm going to click. There's some pictures here. One is a lightning bolt. I'm going to click on that lightning bolt. And what it shows you is these are all the events that we can respond to. And if you look, I don't know how many there are, probably a good 20 or 25. So if I wanted, as an example, there is an enter event here. So if I double clicked on that, it would bring up the button's enter event. All right. So I could come in here and put in a message box. All right. And I could put like .show, and I could say, hi from calculate button. All right, kind of a silly thing to do, but I'm just trying to show you something here. All right, and I'll put in here calculate button enter event. Okay, and I'll just make that an OK button. So the buttons, I'll just add an OK, and this is just information. So under the icons, I'll just make that in information. Okay? All right, so I put that in there. What did that do? It's easiest to show you. So let me run the program. And notice it says hi from calculate button. Why? Because that calculate button had been highlighted. So notice when I come here, and let me move off that button so I'm not there. So I'm going to move over here by here. Now I don't have any other code in here yet, but it says right away, as soon as I touch it, basically, and I could put another one in there. So all I'm trying to show you here is you can put code in any of these things. Well, let's say I didn't want this code in here, but it's like, this is getting disturbing. I don't want it in there. Don't go in and just highlight the code. All right, so do not go in and just highlight the code here. And I'm not sure why it's not showing, but it's not. and just remove it. Instead, in this calculate here, find it, like right here, highlight it, and hit delete. Now it's gone. That's how you remove code that you don't want. If you don't do it the way I just showed you, you will remove it from your code window, but it will still be present in the system files, and that can really screw stuff up because there's an inconsistency between your files and the internal system files. So that's the object, that's the event. Okay? All right. I mentioned the Intellisense already. It will try to help you. I believe there's a way that you can go in and turn the Intellisense off. I would recommend not doing that. Typically, it's going to end up helping you, okay? Because it's starting to give you completions. And if you want to accept something from there, so if I wanted to, for instance, right here, if I wanted suspend layout, I could just hit my down arrow once and then hit the tab key and it would put it in for me. They do mention that when you highlight something in there, a tooltip should be displayed, right? So you can look at it and see if that's indeed what you wanted or didn't want. So these are the invoice handlers that they put in, and rather than me putting those in, because I can't find my program right now, let's instead look at the code that they have here, okay? So we pop back and forth here between page 39, was it 39? Is that right? Yeah. And page, wherever I just was it 55? 65, I think. Yeah. All right. So let me, there we go. So between 67 and 39. So where do we put code in here? You should get this already. We could put code for these labels. You almost never put code in labels. We could put code in here. Why might we put code in here? Well, we could put code in here. As an example, we could put code in here that would check every character as we typed it in. And if that character was not a number, we could refuse to accept it. All right, now there are better ways of doing it, but I'm just trying to prove a point here. All right, for what we're doing right now, for the first several chapters, where we'll put the majority of our code will be in our buttons, and in particular in our buttons click event. So in here, this is the code in that calculate button. So we're saying the subtotal is equal to whatever we put into that text box for the subtotal, and we're doing a convert decimal. Now you've already seen this, you've already heard me talk about this. That will break if you put something, if you leave it blank or put something non-numeric in there. All right. All right. Now I set the discount percent and I set it in a constant to 10%. Here they're making it a variable. Why? Because they're saying if you purchased $500 or more, your discount is 20%. If you purchased $250 through $499.99, your discount percent is 15. If you purchase between $100 and $249.49, you get a 10% discount. Otherwise, there's no discount. But other than that, it's virtually the same code that I wrote. And again, we don't have just a this.close here. We've got that message box that asks the user if indeed they want to end the program. So they give you some coding rules here. These are good ideas. If you don't use spaces to separate your words, typically the editor, the Visual Studio editor, will try to format it for you anyway. This is a case-sensitive language. End each statement with a semicolon, and blocks of code must be within curly braces. All right. There are three major types of errors that you can run into when you do a computer program. The first type is what's shown on the window right here, and those are syntax errors. And those are errors in the rules of the language. So for instance, if in the first day of class, I had come in and instead of saying, hello and welcome to the class, I had said something like class, welcome, hello to, etc. And you probably wouldn't have understood what I was talking about because I would have been using jumbled English. I would have, for lack of better words, been breaking the syntax or the rules of the English language. All right? Well, when you do that in a computer program, the compiler finds those errors for you. So, for instance, in here, we haven't, this txt%, there probably isn't anything named that when it says it doesn't exist. So maybe I spelled percent wrong. All right? Or if I go and leave a semicolon off, those are all errors that are going to show in the error window here, and or error list window they call it. And those are all syntax errors or errors in the rules of the language. So syntax errors are the first of 3 types of errors. All right? The next type of error is what's called a logic error. I'm sorry, let's before we do logic, is a runtime error. So let's take a look in here. Let me come back to this. Whoops, don't want to do that. Let's come back to here. All right, and I'm going to go and click on my exit button. I'm going to pick on this. And I'm going to try something. I'm going to see if I can make a logic or a runtime error. So I'm going to say here, int x equals 7, int y equals 0, int z equals x divided by y. All right? Now, I'm not sure what's going to happen when I do this, but I'm going to say message box dot show the value, whoopsie, and we'll just put in here z. Okay? I'm not sure if this is going to generate the error like I want it to do or not, but we'll find out. Dot to string. All right. So I'm going to run this. I'm going to click exit. And it gave me a runtime error. It's telling me I attempted to divide by 0. All right. Now, the reason this is called a runtime error is this error was not discovered until I ran the program. So it's at runtime. If I had left the semicolon off here, I'd get an error when I tried to run it now. So when I did this, it's going to give me an error in here. So if I say no, basically it comes in here and it's showing me that error right there. That's a compiler error. So that is a syntax error. When you don't discover the error until you run the program, all right, when you do that, then it's a runtime error. So let's say that I have a 7 here, and let's make this a 12. All right, and I want to say z equals, and I want to add these two, but I accidentally put a minus sign there. All right, and I run the program again. Well, I get in here -5. Oh, wait a minute. 7 plus 12 isn't -5. 7 plus 12, oh, I meant to put a plus sign in there and I put a minus sign. That's a logic error. Those are the hardest type to find because when you start programming, you immediately think, oh, I didn't make that error. You did. We all do. All right. So let me jump back in here. All right. How to code with a readable style. Totally legit for you to code like this. That's a nice way of coding. Notice there's white space, there's tabs, etc. However, when the compiler starts to compile your code, it takes this and turns it into this. It removes all unnecessary white space. So you could code like that. It makes it much harder for humans to read, but the computer can work with it just fine. But as they show you here in their recommendations, you should use indentations, blank spaces, blank lines for readability purposes. It's just a good idea to do. Comments, we've talked about this already. There's 2 types of comments. There's a single line comment like you see right here. When you put that // in like this, everything to the right of that // is commented out and skipped. The compiler acts as though it's not even there. If you've got something you want to go over multiple lines, it starts with a /* and it ends with a //. You can pretty it up and put it in a little box like this if you want to do that. You can set this up any way you want, but comments are ignored by the compiler. What they do is they offer what's referred to as internal program documentation. Should you use comments? My litmus test for this is I check and see whether or not, when I look at some code, gee, can somebody else look at it without and understand what I'm trying to do without there being a comment? If I know they cannot, I should put a comment there. If I know they can, I don't put a comment there. If I'm not sure, I put a comment there. So I've added comments to say stuff like this before. Move the focus to that text box, or clear these fields, etc. After a while, you kind of get a look and feel as to when you should put in a comment and when you don't have to put in a comment. The text editor toolbar, that's right there. I did want to show you something in this, and I don't think it was in here originally, but I want to show it to you right now. Where are we? Here we go. So when I come through here, let's say that I was doing this and I was having problems in this routine, and I couldn't for the life of me figure out why I was having problems. And I want to comment all this stuff out. So I can come in here and I could comment each line. I can do that, and it works just fine. Not a problem, but it was kind of a pain. Oops. And imagine that rather than having just 4 lines of code in here, what if it was 40 lines of code? All right. Or I could have come in here and done this. So I could have come in at the beginning, done this, and then I could have done this. And now it's commented out as well. But it's kind of a pain to have to sit there then and remove all that. Well, there's an easier way of doing this. If I take all the code that I want to comment and highlight it and go up into my window up here and there's my run. If I keep going to the right, almost to the end here, I'm going to find a thing that says comment out these selected items. And if I click that, it adds the comments for me. And you say, well, that's what you did before. Yeah, but I did it in one swoop. And if I keep it highlighted and click the one next to that, it uncomments everything. So using those two things is a fast way to comment something out or uncomment it. All right, and that's what they're showing up here. There's other buttons and other things that you can work with. All right. If I decide, let's assume that I've written a ton of code in here, 40 or 50 lines, and I'm done with that. I've tested it. I don't want it to show. You'll notice there's a minus sign here. I can click that, and it collapses it. The code is still there, but it's hidden. If I click it, once it becomes a plus sign, that just means I can bring it back again. It's a little shortcut if you're so inclined to use that. Code snippets, I'm going to let you read this on your own. All right. For using code snippets, so if I wanted some information, if I wanted the system to be able to write a little bit of code for me for the if statement, I could highlight it, and then as it says here, what is it? It's like there's a tools code snippet manager that you can use. All right. I don't ever use this. I want to be able to write my own code. If something goes wrong, I want it to be said that it was my fault, not that somehow the code, the software put in something it shouldn't have. All right, because I'm the one who's going to be held accountable in the end for it anyway. All right. Refactoring code. Now, this is something different. When you refactor code, typically what you're doing is you're taking a routine that you have written that is getting too long to be in one routine. It might be where it started out as 10 lines, and now over time it's grown to 100 lines or more. So when you refactor code, you're typically taking and breaking up one routine into multiple routines. All right? And to do that, as it says, you can take the code you want to refactor, highlight it, and press Control period, and the system will try to figure out a refactoring method for you. Now, I don't typically use that very much because what I try to do is I try to write methods that are not really that long. As of right now, we've been taking our code and we've been putting, for example, into our click event for our buttons, we've been putting in our code. What you're going to notice is over time, that's going to get really, really large. So we're going to take that code that we're putting into our button event, we're going to tear it out of there, and we're going to put it in one or typically more methods. And then we will call those methods from the buttons click event. There's other reasons for doing that, and we'll get into that at a later time. All right, running a project we've already talked about. You can click that start button. You can press the F5 key. There's different ways that you can do this. All right, but the idea is you want this to come up and show, right? All right, every time you run a program, you are in essence testing it. Even if it's something you've run 100 times before and you're sure it works, you're still testing it. Because weird things can happen. You can hit a weird keyboard combination or whatever. All right. So when you are testing, the idea is when you build something, what you're trying to do when you first start testing is you're trying to break your code. Why? Because if you're creating it for someone else, the sooner you break it in the development cycle, the cheaper it is to fix it. But if I had created, let's assume for a second that I created some kind of a program for Rankin, and I had tested it, but somehow when I give it to Rankin and they start using it, now when students use it, it's locking up their computer. Well, it's going to cost a lot more to fix that in that case than it would if I would have discovered the error. So when you test, at least at first, you're trying to break your program. And anytime you break it, you're trying to fix the errors that made it break. All right? And you're also debugging your program. And when you're debugging, you're trying to get those errors out of your program. So it says to test a project, you run the project to make sure it works properly no matter what combinations of valid or invalid data you have. They talk about runtime errors. I've already shown you those. When you're debugging those errors, again, you've seen this already, and I've shown you this before. You can bring stuff up. So again, in other words, if I come back to the program here, let's go back to what we had right here, and let's run it again. This is going to give me an error. I know it. Okay. Oops. It's not going to give me an error because I want to do the divide there. So when I put this in, this will be a runtime error. That's interesting. Oh, it's got to be 0. I'm sorry. Finally, after the third attempt, I should get it right. So this is a runtime error. When I do this, I can show the call stack. So over here, it'll basically show me in a last call to first call order how I got to this point. So this is my call stack. I can view the details. So this will show me the value of everything, and it's meant to try to help me figure out what the error was. I can copy those details, so if I want to throw them into a text file, I can. Start a live share session. I've never done this before, so I don't even know what that does. But over here, I guess if you've got a live share account, somebody will try to help you online, but I don't know. Here we've got an autos window, and you'll notice it's showing us, oh, okay, X was 7, Y was 0, and it's trying to show us that Z is 0, even though Z is technically infinity. So when you get this and this exception window comes up, typically you'll look at the error, and then when you get done, you'll just click the red square to make it go away. Oh, I got to change that. That should have been, whatever, not divide, but multiply, for example. So now when I run it, it's going to say 0 here, but it didn't break, as an example. So when an application encounters a runtime error, you need to fix it. That's the process typically known as debugging, and the error is known as a bug. When it does that, you go into what's called break mode. You're always in one of three modes here. Right now I'm in design mode. Right now I'm in run mode. Right now, putting that back again to a divide. So right now I'm in break mode. All right, I can also do another thing for break mode, and what I can do there is if I want to make sure this is working correctly, let's go back, so I don't want this to break. Let's put in there, let's just put in there 5, and we'll leave it like that. Okay, I'm going to click over here on where the message box is, but I'm going to click way over to the right here, and you'll see when I put my mouse there, I get these dots. That allows me to set a breakpoint. So I'm going to click right there, and you can see it set a breakpoint. All right, now I'm in design mode. Now I'm in run mode. Now it's stopped, and I am in what's called, again, design mode, run mode. I'm in a kind of a debug mode right now, but I can take my mouse down. I can look down here and it says, okay, X is 7, okay, Y is 5, good, and Z is 1. Well, if I divide one whole number by another whole number and put it into a whole number, it automatically throws the decimal place away. The point is, my program is stopped right here, and it stops until I tell it to continue. Okay, now it gives me the answer, and it allows me to quit. If I don't want this breakpoint here anymore, okay, and we're going to have a whole chapter later on debugging, so you're going to see this more and more. It says there in Chapter 11. And that's it. So I'm sorry that this came up, and I will send everybody out this morning. I will send you all out an email explaining the situation and how you can get to this presentation. So that's it. Thanks for watching.